Assalamualaikum and hi everyone. Today I will be introducing to you our assignment for BERT 2324 Data Communication and Networking. Our assignment title is Discovering an Action Dialogue. DAD. In this video, we will explain about the smart car project where we apply the DAD method to get the problem solving process. So let's get started. So this is the team members. Me, myself, Nurulain Sofea binti Noor Hisham, Aieenna Illeeya binti Nurzana, Muhammad Razmer Ar-Ridzwan bin Muhammad Rosli, Muhammad Faiz Adni bin Muhammad Yusri, and Muhammad Iskandar Dzulqarnain bin Ibrahim. Hi, my name is Nurulain Sofea binti Noor Hisham, and my matrix number is B122410474. Let me start with a quick introduction to this project. The smart car IoT safety system was developed using Cisco packet tracer with the main goal of simulating an intelligent vehicle that can automatically respond to safety-related situations. The system handles events like collision, unauthorized entry, and engine overheating. It uses various IoT components such as motion detector, smart door, engine fence, light indicator, dash cam, and a sirens, all working together in a connected private network. These components communicate using IP addressing and are controlled by custom JavaScript code. The simulation runs on Cisco Packet Tracer version 8.2.2 with a wireless router acting as the car main gateway. Overall, the project shows how automation and IoT can increase vehicle safety, reduce human error, and support real-time decision making for drivers.
Assalamualaikum. My name is Mohd bin Yusri. My matric number is B122410421. So today I am going to brief and explain what is DAD is. So DAD stands for a structure method used to solve real world problems. So what makes it special is that it's focused on that what is already working instead of starting from scratch for only looking at what's wrong. It also encourages us to learn from people who are closest to the issues because they often have the best insight. DAD use 7 key questions to help us recover new insight and take meaningful action. This question guide us to think deeper and come up with practical solution. Lastly, DAD promotes collaboration, reflection, and finding local solutions that are relevant to the community or context. So in summary, DAD helps us solve problem by learning from success, asking the right question, and working together to create positive change. So that's all for me. Thank you.
Assalamualaikum. My name is Razmer Ar-Ridzwan bin Muhammad Rosli, and my matric number is B122410482. Let's start by looking at the core problem we're addressing. Step 1. What is the problem? First, road accident and unauthorized access continue to be major safety concerns. This issue highlight the need for better vehicle intelligence and control. Second, traditional vehicles generally lack the ability to respond automatically to hazard, whether that's a sudden obstacle, dangerous driving conditions, or a breach in access. And finally, manual systems are reactive and often slow, which reduce our ability to prevent incidents before they occur. Now step 2, what's working well already. Our sensors are performing accurately in simulation environments, which give us a strong foundation for a real-world application. We also have stable communication between components via IP, so the system is talking to itself reliably. And most importantly, in this system, like fans and light are activating exactly as expected when triggered. These successes show that we are on the right track and give us confidence as we move toward fully automated responses.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurulain Illeeya binti Nurzana. My matric number is 122410478. Today I want to explain step 3 and step 4. For the step 3, what are people doing that helps? Today, many users are already using smartphones and or laptop to monitor their car system. This kind of remote access allow for easily control and oversight. Additionally, manual triggering of safety responses, such as activating alarms or unlocking doors, is becoming more common. These actions show that people are starting to adopt smart technology in their daily visual usage. For the step 4, what's prevent people from doing more? However, there are still several challenges. Firstly, limited knowledge of IoT among students and beginners can slow down adoption and development. Secondly, technically issue like misconfigured IP addresses or coding error can disrupt system functionality. Lastly, incomplete integration of sensor logic, where sensor don't communicate properly with the system, prevent full automation and reliability. Thank you.
Assalamualaikum. My name is Mohd Iskandar Dzulqarnain bin Ibrahim. My matrix number B122410510512. Now, I will continue from step 5 until 7. For step 5, we identify several things that will help this project success. For example, we planning IP address properly so every sensor and actuator could communicate smoothly. We also run scenario-based testing such as crash events, engine startup, and motion detection to validate the system performance. Now, for step 6, we focus on ideas to make the system more intelligent and responsive. First, we implement automatic door unlocking using a motion detector placed near the smart door. Second, the light component acts as an indicator for turning the engine on or off. When the light is on, it means the engine is on. And then the fan, which represents as the engine motor, is linked to the light. So when the light turns on, the fan also turns on. When the light is off, the fan also turns off. Finally, the crash detection system automatically trigger a warning light, activates a siren, and start the dashcam recording for both the front and rear cameras. After testing and identifying what works, we also plan the next action to improve the smart car. First, we will test more crash scenario in packet tracer, including multiple sensor activation add-ons. Second, we aim to improve the response timing of the sensor to make them act faster. And lastly, we will integrate a server-side logging to simulate how alert could be sent to emergency responder or owner.
To wrap up, this project applies the DAT method or discovering an action dialogue, which help guide our innovation using local knowledge and structured interaction. The IoT smart car we developed isn't just a simulation. It represents a scalable solution that can enhance real-world vehicle safety using automation and smart system. Looking ahead, future work could involve implementing this system on real hardware and adding mobile alert integration like SMS or app-based crash notification to make it even more responsive and practical. So that's all from our group. Thank you for your attention.